आज के टॉपिक में हम लोग देखने वाले हैं पैरेलल ट्रांसमिशन. सो दिस इज अ डायग्राम ऑफ योर पैरेलल ट्रांसमिशन. ओके, सो जस्ट 1 minute. Okay, parallel transmission. Okay, so here in parallel transmission of data, okay, parallel transmission of data, all the bits of bytes are transmitted simultaneously on separate bytes. Okay, so here in parallel transmission of data, all the what I'm just 1 minute. Okay, in parallel transmission of data, all the bits of bytes are transmitted simultaneously on separate wires. So here in this figure, you can see that this type of transmission require multiple wire for interconnecting the two devices. Okay, so to connecting require multiple wires. Okay, so parallel transmission is possible practically only if the two devices are close to each other due to the length and the number of wires required. For example, parallel transmission take place between computer and its printer. Okay, example is to what I said here now. This type of transmission require multiple wires, right? So parallel transmission is possible practically only if two devices are close to each other. Means example is computer and printer. So show in this figure the parallel transmission of 8 bits. Okay, the parallel transmission of 8 bits, 8-bit digital data, right? This will require 8 wires. So it is a 8-bit, so it's require 8 wire here for connection between the transmitter and receiver. With increase in the number of receivers, the number of wires will be increased to an unmanaged number. अगर 9 हो then wire also will be increased. So this is about the parallel transmission here. So advantages of parallel transmission is that all the data bits will be transmitted simultaneously. Therefore, the time required for the transmission of n bits word is only one clock cycle. The serial transmission will require n number of clock cycle of transmission of word. Okay, so here serial transmission will require n number of clock. Due to this clock frequency can be kept low without affecting the speed of operation. Serial transmission clock frequency has been high. So disadvantages of this that the transmission n bit word we need n number of wires. Okay, if we want to transmit n number of bits, so we require the number of wires. So it is the disadvantages, right? With increase the number of users, the number of wires increase, and it become impossible to handle them. The serial transmission use only one wire for connecting the transmitter to receiver. Hence, particularly the serial transmission is always preferred. So this is in parallel transmissions. I gave the example printer and computer, right? So in disadvantages, if number of wires required, right? Means if user अगर ज़्यादा user को if they want to use communicate, then it requires the more wires, right? But in serial transmission, in serial transmission, the bits of the bytes are serially transmitted one by one. So in this figure, you can see that the byte to be transmitted is first stored in a shift register. Then these bits are shifted from MSB to LSB. MSB to LSB means more significance bit to least significance bit. Okay, LSB. So here In serial transmission, the bits of the bytes are serially transmitted one by one. Okay, so here serial transmission, it's a one by one procedure is okay here. So here the byte of the transmitted is the first store in the shift register. Then these bytes are shifted from MSB to LSB bit by bit. Synchronization with the clock. Bit are shifted right. Bit are shifted to right. Here bits are shifted to right, and which you can see in this figure. Okay, so and position per clock cycle. The bit which falls out of the shift register is transmitted. Hence, LSB is a transmitted first, and MSB is the last bit getting transmitted. For serial transmission, only one wire is needed between the transmitter and receiver. So, parallel transmission having each user need a separate wire, but in serial transmission, one wire is sufficient for receiver and sender. So the bit which falls out the shift register is transmitted. Hence, LSB, that is the least significant bit, is transmitted first, and MSB is the last bit getting transmitted. For serial transmission, only one wire is needed between the transmitter and receiver. Hence, the serial transmission is preferred for long distance data. So, serial transmission is preferred the long distance data communication. This is the advantages of the serial transmission over parallel transmission. So, this is the advantages, right? Which what advantages here? It prevents the long distance data communication, right? So here the serial transmission has serious drawback, as only one bit is transmitted per clock cycle. It requires a time corresponding to 8 clock cycle to transmit one byte. The parallel transmission need only one clock cycle to transmit a bit. The time can be reduced by increasing a clock frequency. Okay, so practical serial transmission system here. This figure show the practical serial transmission system. The transmitter and receiver both are computers. Okay, transmitter and receiver both are computers. So since the communication within a computer is parallel, it is necessary to convert parallel data into serial one at the transmitter. So here both are receiver and transmitter both are computers. So here communication within a computer in parallel, it is necessary to convert parallel data into serial one at the transmitter. At the receiver, the serial of to parallel conversion is required to be performed as like this. Means, okay, so this is a diagram of your serial practical transmission. Here both are receiver and transmitter. You can say the both are the computer here. Okay, data in the serial form. For so here this is a parallel. This is a MSB and LSB. Most to least and parallel to serial convert and serial to parallel conversion is required for this purpose. So advantages of the serial transmission is only one wire is required. So this is advantages where we can see that in parallel transmission many wires required, right? So that is the disadvantages in parallel transmission, but here only one wire is required to be used. Okay, okay, and reduction is in cost due to the less number of conductors. So here disadvantage is that the speed of data transfer is low, as only one bit is sent at a time. And the disadvantage also in serial transmission system that the speed of data transfer is low. So here because of one wide speed of data transmission, of course it will be low. Yeah, is a low, as only one bit is sent at a time. So here the increasing the speed of data transfer, it is necessary to increase the clock frequency. If you want to increase speed data, then need to increase clock frequency. Okay, so this is the disadvantages. of serial transmission system. So application of is that it is a use for computer to computer communication. This serial transmission system is used for serial computer to computer system, right? Communication, especially long distance communication. So number of wires required to transmit n bits, that is n wires. Okay, so here in parallel transmission, serial transmission see. Okay, so अगर parallel transmission में हम लोगों को number of wires required to transmit n bits, तो parallel transmission में अगर number of n wires है, okay, पैरामीटर में, तो parallel transmission में भी number of n wires ही require होती है ट्रांसमिट करने के लिए bit. But in serial transmission में क्या है, one wire sufficient for transmit the bit. Okay, so this is a difference of parallel and serial, right? And in parameter, number of bits transmitted simultaneously. So number of bits simultaneously transmitted in parallel transmission, n bits required, and in serial transmission, of course, one bit. But in parameter, that is in serial parallel transmission, speed of data transfer fast. Okay, why? Because it's taking the separate wire particular bits, right? So of course it will be fast. But in case of serial transmission, the bit speed of data transfer is low. Why? Because slow, you can say, because we are using one in only one wire we are working, right? So cost, parallel transmissions cost high due to more number of conductor. We require more number of conductor, so what obvious it will be high. And in serial transmission cost low, since only one wire is used. Why? Because we are using one wire, so it is a low. Okay. Application, that is in parallel transmissions, application is short distance communication such as computer to printer communication. Parallel transmission में हम short distance की communication we can do it. And in serial transmission, long distance computer to computer communication भी, can be possible. Okay, so this is a difference of serial transmission and parallel transmission. So types of transmission here. So there are three types. That is a source of type, that is synchronized data transmission, or synchronous data transmission. Okay, and isosynchronous data transmission. So a synchronous transmission, in the in a synchronous transmission, the transmission can bring transmission of data byte at any instance of time. Only one byte is sent at a time. After sending one byte, next byte can be sent after arbitrary time delay, as shown in this figure, or synchronized. Okay. So here in asynchronous, first of all, you know the meaning of synchronized and asynchronized, and in many time we have discussed about synchronous and asynchronous. So you have to understand, you have to know this meaning. Okay, you must know this meaning. So here I will not repeat this asynchronous and synchronous meaning. So it's asynchronous transmission here. In asynchronous transmission, the transmission can be the transmission of the data byte at any instance of time. Only only one byte is sent at a time. Okay, in asynchronous, only one byte is sent at a time after sending one byte. The next byte can be sent after an arbitrary time delay, as we can see in this figure. Okay, so the transmitter and receiver can operate at different clock frequencies. So यहाँ पे जो transmitter receiver है synchronization में और different, they using the different clock frequency. There is a no synchronous between them to on this account. So just a minute. Okay, so here, okay, so you can say that the data transmission can comes at any instant. It becomes difficult for the receiver to understand the instance at which the byte has been transmitted. To help the receiver to receive the data by start and stop, Okay, byte start and stop bits are used and along with each data bytes. So the start bit is always 0 and stop bit is always 1. So here a start bit always 0 and start bit always 1. Okay, so here you can see stop and start. Okay, so asynchronous transmission, the ideal time in between adjusts data byte is not constant. Okay, so the ideal time is also called as gaps between the data bytes. In the asynchronous transmission, the timing of the signal is not important. Instead of information is received, the translate by the patterns which are agreed upon by sender and receiver. As long as these patterns are being followed, the receiver can retrieve the information without any problem. So why is called asynchronous? The mechanism is called as asynchronous because at the byte level, the sender and receiver do not have to be synchronized. So it's called this mechanism is called asynchronous because the byte level, the sender and receiver do not have they both don't have the synchronous time. So that's why it's called the asynchronous. So however, within each byte, the receiver should still be synchronized with the incoming bit. This means some synchronization is required only for the duration of single byte. Response to the start and stop beats. So response to the start and stop beats. This you can see here. So when the receiver detect the a start beat, it will send a timer. Okay, when this receiver detect the start beat, it will send a set a timer and being counting beat as they come in. After n bits, the receiver searches for the stop bit. Okay. Then soon as it detects the stop bit, it will be wait until it detects the next start bit. So the meaning of asynchronous is actually asynchronous at the byte level, but the bits are still synchronized, so their duration are same. So this is about the asynchronous transmission. Then the block diagram of synchronous transmission. Okay, so here the block diagram of synchronous transmission, start bits are 0, stop bits are 1. You can show this figure. So in this figure, that is a asynchronous transmission. The use of start and stop data, bits and gaps, idle time that is between adjacent data unit will make the asynchronous transmission slow. This is the major disadvantages of using the start and stop bits. So disadvantages of asynchronous transmission is additional bits. Additional bits called start and stop bits are required to be used. It is difficult to determine the sampling instance, hence the timing error can take place. The start and stop bits ideal time, that is gap time, makes the asynchronous transmission slow. So advantages of asynchronous transmission is synchronization between the transmitter and receiver is not necessary. So this is the advantages, that is what synchronization between transmitter and receiver is not necessary. It is a possible to transmit signal from the source having different bit rates. The transmission can commerce as soon as the data byte to be transmitted become available. This mode of transmission is easy to implement. It is cheap scheme. It is an effective scheme. Okay, then application of asynchronous transmission is the connection of the keyboard to computer is an example of synchronous. The connection of keyboard, okay, to कंप्यूटर का कीबोर्ड का जो कनेक्शन है, ये एक एग्जांपल है asynchronization transmission का. I hope कि asynchronous transmission now you will get with the help of example also. So synchronization transmission. So the synchronous transmission is carried out under the control of कॉमन मेकर मास्टर क्लॉक. सो यहाँ पे जो सिंक्रोनाइजेशन ट्रांसमिशन है इज कैरी आउट अंडर द कंट्रोल ऑफ कॉमन मास्टर क्लॉक. Okay, so here bits which are being transmitted are synchronized to refer the clock. Okay, no start and stop bits are used. Instead the bytes are transmitted as a block in a continuous stream of bit. So in this figure, in synchronous transmission, you can see that there is a inter block idle time which filled with idle character. Okay, the receiver operates at exactly the same clock frequency as that of transmitter, as both are synchronization with each other. This system essential for error-free reception of data. Flag is a sequence of fixed number of bits which is preferred to each block as shown this figure. Okay, so you can see in this figure, right? Flag is there. Flag is a sequence of fixed number of bits which is prefixed to the each block. Flag is useful in identify the being beginning of clock. So flag ये clock की beginning को identify करने के लिए हम we are using here. So in this synchronization transmission, the bit stream to be transmitted is combined into long frames. A frames will contain more than one byte. There is a no gap between successive frame. The receiver separates the bit stream into bytes for the purpose of decoding. You know the encoding and decoding, right? The start and stop bits are not used. Instead of bit are transmitted serially one after other. The grouping of this bit is responsible of the receiver. So the synchronization transmission, this is a block diagram of the synchronization transmission. So in this diagram, you can see that the blocks scheme of synchronization transmission note the absence of gaps and start stop bits. So advantages of this, the speed transmission is much higher than that asynchronous transmission. This is due to the absence of gaps between the data units, absence of start stop bits. Start and stop bits are not needed anymore. Timing errors are reduced due to the synchronization. So disadvantages of block diagram is the timing is a very important. The accuracy of the receiver data is dependent early on the ability of the receiver to count the receive beats accurately. The transmitter and receiver have to operate at the same clock frequency. This requires proper synchronization, which make the system complicated. So, application of synchronous transmission. This synchronization. The synchronization transmission, due to its high speed, is used for data exchange uh, one computer to another. So synchronization, the bit synchronization is achieved at the data link layer level of for synchronous transmission between computer. So difference between asynchronous and synchronous transmission is synchronization no needed. असynchronization मतलब asynchronization में synchronization की needed नहीं होती है. This is the first parameter. And in synchronization transmission, synchronization is required. In asynchronization transmission, start and stop bits used in asynchronization, but in synchronization transmission, start and stop bit not used. In asynchronization transmission, gaps between data blocks present. Okay, so between the gaps, data blocks is present in synchronization transmission, and in synchronization transmission, absent. Gaps between data blocks is absent. Asynchronous transmission speed is slow and synchronization transmission speed is high. Application of the asynchronous transmission is communication between computer and keyboard. This is the application of asynchronous transmission, means I use. And in synchronization transmission, communication between two computers. So here communication occurs between two computers in synchronous, and communication between keyboard and computers occur in asynchronous transmission. So this is about the comparison of synchronous and asynchronous. Here we see that here synchronization, no need of synchronization in asynchronization transmission, and synchronization is required in synchronous transmission. So this is about synchronous and asynchronous transmission. So isochronous, this is the third type of serial transmission in the real time streaming of audio and video. Isochronous, it's the audio and video is the example. The time delay introduced during the transmission must remain constant. Uneven time delay will introduce distortion. Such application we cannot use the synchronous serial transmission usefully. The asynchronous transmission can be used such application. Okay. Digital to analog conversion. We have already seen digital to analog conversion here. So let's draw a diagram first. Okay. So digital to okay, 1 minute. Digital to analog conversion. Digital to analog. Okay. So for this purpose, we want just 1 minute. So this is a diagram of digital to analog conversion. You are so here we require this for this is a digital. You know the meaning of digital and analog, right? What is the digital and what is the analog, right? We have already seen this difference and difference between analog and digital. What the name of why we digital means what and analog means what. Signals performance of digital and analog, right? We have seen in starting of the point only. So this is a digital data. Okay, digital data, and this is the analog data here. After this is the analog. Okay, analog. So here digital data, here analog signal. Okay, so here this digital data will be convert which form in this form. Okay, wait, like this. Okay, so the in analog signal it forms waveform, and digital is which we have studied already. Okay, or non-continuous form. So so digital to analog, the two most important aspect related D to A means digital to analog conversion are as started means data element versus single element, data rate versus single rate. Data element versus single element, that is, we may define data element as the smallest piece of information that can be exchanged, and we as we know it is bit. The single element is classified, defined as the smallest unit of single, that is a constant. This definition is true in the digital convert, but the single will be analog there here. Hence, the nature of the single element is slightly different than that for the digital transmission. So data versus single rate is look like this. Okay, we have to do this one. Okay, here only see, and the formula of data and a single element is n into 1 by 8. Sorry, 1 by r. Okay, so we have defined the data rate, bit rate, and single rate, the bound rate earlier. The relation between them is for the single rate, that is a s equal to single rate. Okay, s equal to, okay, signal rate, that is s equal to n upon n into r, n into 1 upon r. So n is nothing but data rate. Okay, data rate, that, and r is nothing but number of data element number of data elements in one signal. Okay, elements in one signal. Okay, one signal element. So the value of r in the analog transmission is as follows, that is r log to l, where l is a type of signal element. So note, bit rate is equal to number of bit per second, bound rate is equal to number of signal element of symbol per second. In the analog communication of digital data, bit rate is always greater than the equal to the bound rate. So in next lecture we will discuss the example of this bandwidth. Okay, and we will see the need of digital conversion wire modulation, types of digital carrier modulation. Okay, so today's lecture over here. Thank you.